How many ounces of 20% hydrochloric acid solution and 70% hydrochloric acid solution must be mixed to obtain 20 ounces of 50% hydrochloric acid solution? Just as we would with any system, we begin by defining the two variables. The two things that we do not know in the problem are the amount of the 20% hydrochloric acid solution and the amount of the 70% hydrochloric acid solution. So we're going to let X be the amount of the 20% hydrochloric acid solution. We follow that with a Y, which will be the amount of the 70% hydrochloric acid solution. When we write the equations for a mixture/solution problem, we write two equations. The first equation deals with the total amount of ounces that are going to be in the mixture, or milliliters, or whatever the unit of measurement is. And the other one deals with the amount of the actual acid or alcohol or whatever might be part of the solution. So the first equation is going to deal just with the total amount. We contribute X of the 20% solution, we contribute Y of the 70% solution, and we want to make a total of 20. The second equation deals with the percentage parts of the two different solutions that are going to get mixed together. So if I take the 20% hydrochloric acid solution and I mix some of that in, only 20% of that is actually contributing hydrochloric acid to the solution. If I take some of the 70% mixture and mix that in, only 70% of that part is contributing hydrochloric acid to the solution. My goal, or the target for adding those two in, is to obtain a 50% solution that is 20 ounces total. A 50% hydrochloric acid part in a 20-ounce total solution. Because we know what 50% of 20 is, we can take this out and replace it with a 10. And this seems to make logical sense at this point. Here, we indicate that we need a total of 20 ounces mixed together. Here, we see that half of that needs to be hydrochloric acid solution. Now, obviously, if I only used this, that wouldn't be enough hydrochloric acid solution. And if I only use this, that would be too much hydrochloric acid solution. So we need to be able to mix the two of them together to ensure that we end at the 50%. Now we have a system that we can solve. While these are both written in standard form, you might discover that it's a little bit easier for questions that look like this to solve them with substitution. It saves you from having to multiply one of the equations by a decimal. Yeah, you're going to have to do some decimal work down here, but it saves you from having to multiply this equation by a decimal, or this one by a whole number, and this one by another whole number. So we're just going to solve for one of the variables, and I chose X. So X is equal to 20 minus Y. So we have 2/10 times 20 minus Y, here comes the substitution, plus 7/10 Y is equal to 10. Solving that down, and you can check my algebra if you'd like, but you should end up with a solution of Y is equal to 12. Because Y is equal to 12, we back substitute this number into here, and we can get that X would have to be 8. So our solution is that we end up with 8 ounces of the 20% hydrochloric acid solution and 12 ounces of the 70% hydrochloric acid solution. And it wouldn't be a bad idea if you had time to take those two numbers and check them into this equation. The whole point of solving a system is that that point will work in both of them. So you want to make sure that it would actually work, putting an 8 here and putting a 12 here. This would become 1.6. This would become 8.4, and together they make 10, and that work checks out.